You ever stop to think about what's actually running the show inside your computer or your phone or even your watch? There's this ghost in the machine, right? This invisible thing we call the operating system, managing everything. But here's the thing. It wasn't just invented, it evolved. We're going to dive into that story, how the OS became what it is today, not through some grand plan, but by constantly adapting to solve one problem after another.
And really, the best way to get your head around this whole story is to think of it like natural selection. Seriously, every single feature, every design choice in an OS, it's a trade-off. It's a constant push and pull between two huge forces, what the hardware can do and what we want it to do. And as those two things kept changing, well, the OS had to evolve, or it would just become extinct.
All right, so let's rewind. Way back. We're talking the 1940s. Picture these first computers. We're talking massive, room-sized beasts like the ENIAC. Back then, the operating system, well, it was a person. You had a programmer, literally standing there, flipping switches, plugging in wires to load a single program. Think about that. The machine itself cost a fortune, but a person's time? That was the cheap part of the equation.
And the number one enemy in this environment, the thing they were all terrified of, was idle time. I mean, every single second that multi-million-dollar machine just sat there, humming, waiting for some person to set up the next job, that was just money burning. The big challenge wasn't even about the calculations, it was about how to keep feeding this incredibly expensive beast without any downtime.
So you can see the first big trade-off right there. On the plus side, it was interactive, I guess. You could literally stand there and watch the lights blink and see your program do its thing in real time. But the downsides? Oh man, they were huge. It was painfully slow, super easy to make a mistake, and just crazy inefficient. The machine could only do one thing at a time. It couldn't compute while waiting for you to flip a switch. So the mission was clear. The first big evolutionary pressure was, we have got to kill this idle time.
Okay, so that leads us to the very first major adaptation. We're in the 1950s now. The big idea? Let's automate the human. Let's get the person out of the loop. The solution was to create a simple program whose only job was to run all the other jobs, one after another, automatically.
And this whole idea was called batch processing. It worked like this. A tiny little program, they called it a resident monitor, just lived in the computer's memory all the time. Its one and only job was to grab the next task from a stack of punch cards and just run it. No coffee breaks, no clumsy fingers, just a machine relentlessly focused on keeping itself busy. And the logic behind this first baby OS? It was so simple but so powerful. Basically, is there a job in the line? Yep, okay, grab it. Run it all the way to the end. Don't stop. And when it's done, immediately grab the next one. That simple loop was an absolute game changer. It slashed the idle time between jobs.
But you know how it goes with evolution, right? You solve one problem and a new one pops up. So we got rid of the slow human, only to discover the CPU was still sitting around doing nothing. But why? This time, it was waiting on slow mechanical stuff, like tape drives and card readers. I mean, the CPU was a speed demon. It could do millions of calculations in the time it took for a tape to spin up and read one piece of data. So yeah, the idle time monster was back, and it had a new face.
This sets the stage for the next giant leap forward in the 1960s. And this idea, this one, is the foundation of pretty much all modern computing. The question was, what if, instead of just waiting around, the computer could learn to juggle? What if, while it was waiting for that slow tape drive, it could switch over and work on something else?
That, right there, is the core idea behind multi-programming. It's a huge deal. Instead of running one job from start to finish, the OS keeps a few jobs loaded in memory all at once. So now, when job A has to wait for I/O, the OS doesn't just sit there. Nope. It instantly puts job A on pause and gives the CPU to job B. And if job B has to wait, fine, switch to job C. It's this non-stop juggling act, all with one goal. Keep the CPU, the brain, the most expensive part of the whole system, busy 100% of the time.
Okay, but how, right? That's the big question. It sounds amazing, but how does a computer actually switch between tasks so fast without everything just, blowing up? This is where it gets really cool. The solution wasn't just software. It required two brand new features built right into the computer's hardware.
First up, you have the interrupt. The best way to think of it is like a little tap on the shoulder for the CPU. So when that slow disk drive is finally done grabbing the data it was asked for, it sends a physical signal, the interrupt, back to the CPU. It's basically shouting, "Hey, I'm done over here. You can come back to that program you put on hold." It's the physical mechanism that makes the whole juggling act possible.
The second piece of this puzzle is called dual mode operation. And this
This is the safety net. It's absolutely critical. The hardware can now run in two different modes. There's user mode, which is where all your normal programs run, and it's very restricted. Then there's kernel mode, the God mode basically, for the operating system itself. All the really dangerous, powerful instructions like directly messing with hardware can only happen in kernel mode. This is what stops one buggy app from bringing down the entire system. It's a firewall built into the chip.
All right, let's fast forward a bit. We're jumping to the 1980s, because this is where the entire game changes. The whole economic equation of computing gets flipped on its head. All of a sudden, hardware is dirt cheap, and human time, your time, is the expensive thing. So the focus of OS design completely pivots. It's not about making the machine efficient anymore, it's about making the person efficient.
I mean, just look at these numbers. They're mind-blowing. The raw computing power, what we call MIPS, it didn't just double or triple, it exploded by a factor of almost 1 million. RAM went from 1 megabyte to, well, now it's gigabytes. But the truly insane number is the cost. Back in '83, 1 unit of that processing power would set you back 100 grand. Today, it's literally pennies. We're not talking about gradual improvement here. This was a straight-up explosion of accessible power.
Yeah, let's just isolate that for a second. The cost of computing power dropped by over 99.999%. Think about what that means. When something that powerful becomes practically free, you can afford to waste it on luxuries. Things like fancy graphical interfaces with windows and icons, networking, all the things that make a computer easy for a normal person to use. The OS could finally focus on serving you, not just serving itself.
And that really brings us right up to today. Those evolutionary descendants of the first simple operating systems, they're in everything now. And the amazing part is, those core ideas we just talked about, managing resources, juggling tasks with interrupts, the safety net of dual-mode operation, they're all still in there. They're just the ancient DNA that is now adapted to this insane variety of new digital ecosystems.
And just like in biology, this has led to some incredible specialization. You've got different species of OS now. There's the real-time OS you'd find in a car's brake system or a factory robot, a species that evolved to never, ever miss a deadline. Then you've got the tiny embedded OS in your smartwatch, which has evolved to sip power as slowly as possible. And at the other end, you have these massive, sprawling, distributed operating systems that run the cloud, a species that lives across thousands of computers at the same time. So there you have it. From a person literally plugging in wires to this invisible ghost that runs the entire planet's data centers, the operating system has never stopped evolving. But the key thing to remember is, it's not finished. The evolution is still happening. So what are the next big challenges, the next predators? Is it the massive demands of AI? The threat of quantum computing breaking our security? Or maybe it's something as simple as creating devices that can last for weeks on a single charge. The process of natural selection for the OS is happening right now.